Found someone new now. I have more room, no more formats to chain me. On the same page, we are effortless, schemaless, living in the future, you and me, made for us, serverless, living in the future of the clouds.
Hey everybody, thanks for joining. If you would please, we're doing a quick sound check. Just give me a thumbs up in the chat if you can hear me. It's not good. I don't see any thumbs up. Oh, I see a thumb up. Thank you, Rags. There we go. Awesome. All right. Give it a few minutes for everybody to roll in here, and then we'll get started. So if you don't mind, just hang out for a minute or two. Thank you for all the thumbs up. Appreciate it. Makes my morning. Tell you what, as we're getting started here, I'd love to see where's everybody coming from? Where are you today? I'm in Louisville, Kentucky in USA. I'd love to hear in the chat. Present. Let's hear where you're from. Phillips in London, cool. Rags in Bangalore, awesome. Paris, India, Edinburgh. Dude, we're covering the globe. This is awesome. Taiwan, India, Dublin, Nigeria. Wow, cool. New York, awesome. San Fran. Cool. Nashville, what up, Nashville? Knoxville, awesome. My wife's from Knoxville. Great town. Okay. I think we're going to make this happen. Thanks, everybody. Man, what a great crowd. Awesome. So, welcome. Thank you for joining. Today, we are going to be doing an intro to event streaming and change data capture. So what that means is we're going to kind of get a little deep and definitely hands-on in thinking about event streaming. And we're gonna look at the Pulsar actually as our broker for doing that. Then we're going to change gears and we're going to talk about some Astra products, Astra streaming, and how it makes your life a little bit easier. You're going to get a little bit of product push there, I warn you. And then we're going to change over to switch over to change data capture. And we're going to talk about that pattern and what are some components within that pattern to complete the pattern. And then how is Astra going to make your life easier there for CDC and how to fill that pattern. So first, as we get into this, I am David. Hi. I am a streaming developer advocate at DataStax. I possess some slight superpowers, I think, with .NET. Don't hold that against me. You're going to see Java in here. I feel a little odd saying that, but whatever. I've been writing code for longer than I'm going to admit. I've spent a lot of time with Kubernetes. I've spent a lot of time in app modernization. So a lot of microservices stuff, a lot of monolithic stuff, a lot of containerization stuff and all that, which of course gets you into CI/CD and building pipelines and all that. So I hope that I'm going to be speaking I'll be speaking objectively today. I will try to keep the opinion out as much as I possibly can. I will say, and I warn you now, that really the only opinion that I'm going to put in this is I have a clear bias towards the Pulsar, Apache Pulsar project, as you're going to see in here. And to tell you the truth, yeah, it's part of my job, but I'll be honest that I think I would be doing this either way, even if I wasn't getting a paycheck, because this project, the design of Pulsar, the cloud native aspects of Pulsar, how deep I am into Kubernetes, into modernization, microservices, the cloud native thing just really, really resonates with me for Pulsar. So I'm kind of a big advocate of the project. So first, let's get into a little bit of housekeeping as we go along. Meet the rest of the team. There are a lot of us. All of them are Jedis. Have no doubt about that. Every one of them are certified Jedis. But we have a few of them in the chat today. If you have any questions or anything about the team, about DataStax, about Astra, or about Pulsar, or any of that stuff, feel free, drop it in the chat, and I or somebody else will definitely get back to you here. Also, you're probably on YouTube right now watching this. We do have the DataStax Devs channel on there. We also have a Discord. And after today, or after this session, the Discord is a great place to get on and ask questions and further learning, discovery, that sort of thing. Pulsar also has its own Slack. And then, of course, the DataStax has its own Slack. Like all of these places, you can ask all kinds of questions about things. Obviously, the Pulsar one is mostly Pulsar based, but the DataStax one is Pulsar based, is Astra based, is just generally like, how do I do event streaming? What are some good patterns there? We're all in there all the time. So you can ask anything. It's a very open, welcome place. Today, we're going to be using a couple of different technologies. When we get into the hands-on part, we're going over to GitHub, to a open repo over there. That GitHub repo is going to have you click on a Git pod link. And if you aren't familiar with Git pod, it's more or less a pre-configured Visual Studio, or sorry, VS Code space in your browser. So there's no drivers, there's no pre-configured anything, got to pull the repo down and then, do this and that and everything. We're past all that. Thankfully, we're past those days. Now, I've already made the Git pod, the configuration for it. You're just going to click a button. It's going to spin up an environment for you. We're going to have fully running Pulsar in there, and we're going to start firing off some commands and get into things. We're also going to get into Astra a little bit. This is a DataStax session. And so we're going to talk about DB and streaming and how we use those things and how we complete the CDC pattern and things like that. So Once we get through the workshop, there's going to be one lab, one hands-on lab. Then we're going to get into 2 demos where you can play along if you want to, or just hang out and watch and, let's converse about these things. Afterwards, after this session, there is some homework. And if you'd like to complete the homework, I promise it's really, really easy. If you'd like to complete the homework, we're going to give you a badge because you need a badge. We have a lot of badges of different things, of different workshops and things that we've done. This one is going to be the Change Data Capture Workshop badge. And you get to take that and frame it and put it on the fridge, because this is worthy of putting in the kitchen on the fridge, your Change Data Capture badge. I'm just saying, it's pretty awesome. Okay, with all that aside, I think we're going to go ahead and get started. I'm going to look back at all my Jedis in the chat and make sure that we're all covered here. Everybody's good. No questions or anything like that. Doesn't look like it. Cool. No lightsabers. I know we need lightsabers. Somebody tell support at DataStax that we need lightsabers, because we do. Okay. So let's get into Pulsar first and talk about, well, why I love that project. So there's a lot of vocabulary around like event streaming, message brokers, queuing, event queuing. I don't know. There's a lot of different vocabulary around this. And the one thing that I want to level set with is I'm going to say event streaming, because I think that that represents the work and the pattern well for this. I'm saying message streaming as well. It's just in terms of saying the word message versus event, I feel like event better represents things that could be happening, with a message broker. It is a message, though, in the end. So they're the same thing. Basically, what you're doing is in this system of streaming, we're watching for events within the system or an application, right? So events happen. Event is represented as a message. A message is some amount of information, right? Possibly encoded, maybe not encoded, I don't care, but it is some amount of information that could be relevant to others watching for certain types of messages, right? So you publish messages, you receive events. That's kind of the idea here. The hope with the streaming system, and thus the word streaming, is we're making decisions on data in real time. Now, Pulsar is going to introduce a pretty cool function or a pretty cool feature where you actually don't have to be real time. You don't have to have consumers on a topic that is actively getting messages published to it. That's pretty cool, but that we'll get to that later. But it's about making decisions on data in real time. And the other thing is you can ingest a high frequency of messages over very low latency and consume at a different rate. And this one I really call out in a streaming system, because I expect this of any streaming system that I would be implementing or using, consuming. And that is, the best way to think about this is IoT, right? So you have a bunch of different sensors. Let's say it's on a car. You have a bunch of different sensors on an engine, and it's offloading a lot of data very quickly, right? And while, yeah, you could miss some data points here and there, you really can't stand to miss very much. And you need to take the information in very, very quickly. But your services behind that, they're going to process the data, writing to a data store, doing some sort of ML stuff, whatever. Those just aren't as fast as the sample rate of what the data is coming off of the sensors. And so a streaming system is perfect to put in between there, because it can take in the messages. All it's doing is taking them in. It's not making many decisions at all. So it's very, very fast at doing that. It's a very low latency to say, yeah, I got it, thanks. But then your consumers on the back end can consume and watch at a much different rate than that. So that's when you get into event streaming and streaming in general, that's one of my big requirements for it. So moving on to Pulsar. Some high points about the Apache Pulsar project. It was originally created by Yahoo. It was brought into the Apache Foundation in 2016. it grew very, very quickly in contributors and code and all that good stuff, and was promoted to be a top-level project in 2018 and has been there ever since. As I said before, Pulsar has a cloud-native design. And I know cloud-native means a different thing to everyone out there. But basically, the Pulsar and all of its components are very detached from one another and are stateless as much as possible, right? And so you're going to see that the Pulsar broker, the message broker, is stateless. And now if we're stateless, we can scale horizontally very, very far with it. It's just about processing messages. The stateful side of it, possibly a store or something like that, is detached from the broker. That's pretty huge, in my opinion. Also, the functions and everything within, those are also detached. And so the thought of how asynchronous am I going to go? How many threads do I need to open or allow for a function to run, or many different instances of a function to run? Things like that, when you get into the cloud and such, those have all been thought out here with Pulsar. And that's why I love this project so much for my microservices and all that, the asynchronous nature of it. It also has a very nice guaranteed message delivery system, but it's not ridiculously convoluted, in my opinion. It's more of a, was it delivered or not, right? That's really what it should be. It should be that simple to do. And it's like, if it wasn't delivered, then leave it there for some amount of time, right? I've found in other brokers and messaging systems, the whole guaranteed delivery thing either doesn't exist or is like a suggestion. It's more of a hopeful kind of thing or something. And it's frustrating because that's a big deal, right? When you get into messages. Very lightweight, serverless functions and framework. We'll get into that. We'll go down there. And the tier storage offloads. So this is kind of cool. So you have your broker, which is bringing the messages in. That's working in memory. Then it's working with an actual persistent store, a bookkeeper behind the scenes. And then also you can have what you could think of as maybe a cold storage. So that's like S3 or something like that. S3 storage, S3 compliant, whatever. And so that is yet another layer. And so those tiers of storage, right, from memory to bookkeeper, that's on disk, and then to S3, which is kind of on disk as well, or some other cold storage back there. And Pulsar handles all of this for you. More or less, it just comes down to time to live numbers more than anything. I see my name was mentioned in here. Get into that coming up with JMS World. What's JMS? I don't know. I'm not talking about that. I'm kidding. Yeah, we can definitely touch on JMS and all that kind of stuff. Okay, so the cloud native architecture here. So some vocabulary for you. We have a producer, right? That is an application, that is a service, that is something creating messages. And we have a consumer. That is an application, that is a service, something watching for messages and consuming them. They both interact with a broker, and that's the Pulsar broker. The broker is a server instance, right? A VM, however you want to put that. It is ultimately a process running in Linux, right? So you could run it anywhere. It doesn't have to be like its own VM or anything. It's stateless, so it can horizontally scale very well, very easily, right? Which is why our diagram here depicts two brokers serving. And then behind the scenes, in the cluster, you also use Bookkeeper, and Bookkeeper has the notion of bookies. And so those are just storage, right? Those are, if you want to just think of them as simple VMs running Bookkeeper that's set up to store Pulsar messages. That's as simple as I can put it. And so Bookkeeper, the Bookkeeper project, is an Apache Foundation project, and it has a whole schema for how it saves information and how it segments things out. And when we get into partitions and all that kind of stuff, it aids with all that kind of stuff. Again, bookies can be horizontally scaled within the cluster, right? So you can have multiple bookies. All of this is going back to latency. right? Because everything's writing to everything here. Everything's communicating with everything. The more you have, instances you have of them, the more requests you can handle at a given moment, thus the less latency you're going to have in the system. I'm just reading the chat a little bit. Kafka versus Pulsar, the timeless, the inevitable topic that everyone gets to talk about. Yeah, we can go there if you want. I'm quite honestly, in my opinion, I wasn't really planning to get down that deep. We're talking about Pulsar here, but the weighing of Kafka versus Pulsar, like that is an age-old tradition, comparing the two and deciding which one is better. Obviously, Kafka's been around longer than there, so thus the project's more mature and all that sort of thing. The last one I want to point out here is Zookeeper, right? And so Zookeeper is, technically, I think it would be called a metadata or metadata store, meta information store. Anyway, it's configuration, right? So your broker is stateless. So something else has to be holding its configuration. When you spin up multiple instances of it, it's got to get its config from somewhere. Same with bookies, the bookkeeper stuff. It's got to get its configuration from somewhere. And then if you're running like georeplication, or you're running multiple clusters, Pulsar clusters, maybe everything needs to share the same configuration, or somehow have some mutual understanding there of what's going on. And so that's Zookeeper, holding all that information. It is just a key value store, metadata store, whatever kind of fancy word you want to use there. But that's where your configuration lives for all this stuff. Okay. So now we're going to get into some fun stuff here. We've touched on Pulsar. You kind of get the idea of where I'm coming from with the design of Pulsar and how we're going to use it, or why you would be interested in it. I think now, I know that was a bit fast, but I think the best thing to do, especially given this crowd, is to get hands-on, right? And just try it and just see how simple this might be. So as we go along here, I'm sure a lot of you are grabbing this. I'm going to ask one of my Jedis, if you would please, to paste this link, or actually I could probably paste the link in the chat. Yeah, there we go. So the link's in the chat. If you want to go in there and grab it, because I'm sure trying to decipher this off the page is pretty painful. And so what we're going to do, I'm going to walk through this AWS Kinesis in short while comparing Pulsar versus Kafka. Yeah, Chip, quite honestly, that's going to be a different discussion. I wasn't really planning to cover too much competitive stuff with Kinesis versus Pulsar versus Kafka, although that's a real topic for sure, comparing the two and the benefits between all of them. My goal here is to really introduce Pulsar and some of the benefits there, or the Pulsar project, and then obviously we're going to get into CDC and that sort of thing. So I'm going to kind of walk along as we go here. I'm going to walk along the lab and do the steps and narrate some things that maybe weren't able to be expressed during or in the steps and all that. The link to get to this GitHub repo is in chat. So please go over there and just, hopefully that's as easy as clicking. If you're not familiar with Gitpod, I'm actually going to open this up in a separate window, because if you click on this button, it's going to open up in the same tab here. So I'm going to right click and open up in a new tab, so I still have the repo open. That is going to pull the container image and do some sort of all kinds of fun things there and get the environment ready. Please be patient with the environment. Once it comes up, then it's got to download Pulsar, the binaries and all that, and put them all in a good place and get everything prepped for you. So please be patient while that pulls up. Here we go. Your theme, I changed my theme because in developing this. So this is VS Code, right? If you haven't seen this before, this is straight up VS Code. So if you want to change your theme over, I'm mandatory dark theme for everything myself. All right, so things are moving along here. Again, give it a chance. Okay, so when the README pops up, the Getting Familiar with Pulsar Broker README or Markdown pops up, then you know you're ready to go. And so as we get into this, let me just kind of give you the lay of the land of where we are. So in VS Code on the left, we have our navigation. That's all the files in our repo. On the right, the main window here is where we're going to have, where we can have the steps and where we're going to be interacting. Well, actually, where we're going to be reading the steps and copying and pasting some of the commands and all that. And then below this is a terminal window. And in fact, if you look to the terminal window just to the right, there are two different terminal windows open. One of them says Pulsar Broker. Guess what that is? And the other one says Working Directory. That's where we're going to be. The Pulsar Broker one is a Pulsar broker running, right? Long running process. I've actually spun it up here in the current thread in focus. So you can actually watch as things happen. We're not really going to come over here too much, but I just thought it might be interesting to be able to see the actual Pulsar process running. We're going to stay over in the working directory and work out of there. And you should have been dropped right into the Apache Pulsar directory, like everything's ready to go here. So if I've done my job correctly. So we're going to get familiar with the Pulsar broker, right? And so the first thing, understanding the Pulsar's design, is how you actually run Pulsar, right? And so they refer to these as the binaries. And so in this directory, if we just ls this, let's give a better one. So in this, we downloaded Pulsar, the distribution of Pulsar. That's the open distribution. There's no magic there. Everybody's got the same thing. And when I extracted that artifact out, I have these folders in there: bin, conf, data, so on and so forth. Right now, really the only one we're interested in is bin. And inside bin, let's just have a look at that. Those are the executables. So I've got a bookkeeper, I've got a Pulsar, Pulsar admin, Pulsar client, Pulsar daemon, all these different executables in here. And that's what we're going to use as we go through this. Now you'll notice all the steps are relative to the bin folder. So we're going to stay in this Apache Pulsar folder. But what I just want to show is we got the artifact, we extracted it out. There is a bin inside of there with all the executables, and we're going to run the executables. Now, the one thing in the background that has been done is Pulsar has already been started, and it's been started in its standalone mode. And so basically it took care of Zookeeper, Bookkeeper, the Pulsar instance, like everything's been taken care of, spun up in memory, right in process, and you can just start interacting with it. All the defaults are there for it, right? So it feels a bit magical there because it kind of is. It just took care of that. You can get in deep and get into the comp folder and change the configuration of the broker. Where is my broker? How are my binaries interacting with the broker? Is it HTTP or is it over secure socket? All that fun stuff, you know, that's for another day. We're just kind of getting introduced to Pulsar right now. So as we get into this, the constructs within Pulsar, I got to allow. The constructs within Pulsar are first, it introduces the idea of a tenant. And the way that I think about a tenant is it could be a product line or maybe a developer team. Because I do have a history with Kubernetes, I tend to try to put that towards clusters and namespaces and all that within Kubernetes. And Pulsar uses the word namespace. Unfortunately, it has nothing to do with Kubernetes. So it just so happens that they both use that same vocabulary, or I guess a word for the construct. But tenants, think of those as maybe a developer team, right? A team of people logging in. Think of it as a product line. But the key thing is that the information within, the messages coming in, are secluded to that logical tenant, right? That thing. Within a tenant, then you're going to have namespaces in there. And so namespaces, I mean, I guess you could kind of think of them in a Kubernetes sense. I honestly, I think of them more when, like, if any of you all are programmers and you're familiar writing code and you have to namespace, if you're using object-oriented code, and you're going to use namespaces within your C# or Java or something. That's kind of where my mind goes here thinking about this. You're inside the tenant, right? So everybody can more or less access it within the tenant. But now you want to logically separate out maybe your environments, right? Something like that. Or maybe, you have within this line of business, you have different domains, right? There's account, there's catalog, there's shopping cart, there's something like that. That's maybe how we could do namespaces. It's really up to you. We're using all the predefined stuff here. So the tenant in this case is going to be public, the word public. The namespace here is going to be default. That's all built in, has all been started up in the standalone mode. And then finally, the lowest level, we have a topic, right? So we have our tenant, that's our line of business. Then we have a namespace, that's some logical delineation of what kind of messages are coming in. And then we have a topic, and that is, you can think of the actual holder of the messages, right? So that is your categorization. What type of messages are in here? What commonality do all these messages have? That's your topic that you're going to use. I hope that's pretty clear. If it's not, please drop some questions in chat. We're happy to. This is definitely an interactive session for everything. So as I'm narrating all this, I've run a few commands, and basically I'm just making sure that I can interact with the Pulsar broker, right? And I did a few queries to say, what are the tenants loaded? This was all automatic stuff. Inside the public tenant, what are the namespaces? And then inside the public default namespace, there are no topics, right? And that just confirms that more than anything. Okay, so now that we've done that, now we're going to switch on to the next module. And by the way, I'm honestly, I'm kind of regretting using this navigation, but if you noticed, as I got down to the bottom of this markdown, I scrolled back up to the top to the next module. I have found if you double click it, I'm on Windows. So if you double click it, it will automatically load the next one real nice and clean for you. Otherwise, when you single click it, it opens up the markdown and you have to, on the right, open up a preview for it. And I'm regretting following that because I think that's a little too convoluted. So my apologies for having to work through that. Good, okay. So now in this next module, now that we've kind of confirmed we have a working broker, we can interact with it, the world is taking shape. Now let's do a little super basic pub sub, right? I'm going to make sure that there was a question in here. I hope we're all covered, Stefano, for questions. Just let me know, Stefano, if you want me to do anything. Cool. Okay, pub sub, otherwise known as publish subscribe. This is the most basic, simple of patterns that you're going to have when you're doing event streaming, right? I publish messages, or something publishes messages to a topic, and then something else consumes those messages or subscribes to watch for messages on that topic. And the two work, they're disconnected about how they work, but they're both looking at the same topic, watching messages, doing some amount of work here, right? That's the pub sub pattern. And so what we want to do here is, in the most simple, basic way, we're going to complete this pattern. And so the first step is we're going to publish a message. The command is called produce. Produce and publish, the exact same thing. Just everybody uses different words for this. But we're going to use the Pulsar client binary. We're going to produce one message. The message is hello there, It's a string of hello there. And we're actually going to publish 2 of those messages right out, publish 2 of those messages. And we're going to our persistent namespace public default, and we're going to let Pulsar create a topic called my first topic. Again, we're in a fairly loose environment here, and we're letting Pulsar, whenever a producer or a consumer shows up asking for a topic, it will automatically create that topic if it doesn't already exist for it. So that's what we're going to do here. So this is going to spit out a bunch of information. Quite honestly, unless I get some red errors or something, I pretty much ignore the top half because it's just a lot of debugging and logging and such. The key thing I'm looking for is 2 messages successfully produced, right? So that means the string hello world, 2 messages with that string inside of it were published to the my first topic, right? Okay, I hope that was understandable. Next, we're going to consume that, right? I want to see those 2 messages. And so we're going to use the consume command on the Pulsar client binary. Notice we're going to do earliest shared N1 as subscription. So I'll give you a quick rundown of this, what that means. Within Pulsar, you have a lot of decisions, a lot of really choices about how you want to consume messages, right? This is a super powerful thing because, in my opinion, it's just so straightforward. In working with Kafka and Rabbit, and of course, this is my opinion, it's very difficult to really manipulate and understand, like, this is the point in time when I want to start consuming messages. Or the obvious, hey, I showed up, just start giving me all the latest messages, right? That's what I think most people assume. But there's another way here. Pulsar kind of introduces the notion of what I think as a playlist, right? When you create a playlist in Spotify or something, you load in all the songs, and you either start at the first song in the playlist, and then it just goes, or you start at some other song within the playlist, and it starts there, and then continually plays the songs after that. That's kind of the idea here of what Pulsar lets you do. You can show up at any moment and start consuming messages for it. So it's kind of cool. So the -P switch there is earliest. And so that's saying, go back to the beginning. And I want the earliest non-acknowledged message in the queue. Shared means when you create a subscription to watch messages here, let others also use this subscription to watch information or messages. The -N switch is just saying, give me one message at a time for it. That's just because we're doing this super easy. We had to name our subscription of how we're going to be watching for messages. And then we had to tell it, here's the topic that I want you to associate the subscription and look for messages on. So we'll do that. And we're going to get a whole bunch of stuff back, a whole bunch of logs back. And the key thing is, though, out of all of that, we're going to get one message back. Why didn't I get one message back? When Pulsar earlier shared, what did I do? My first topic. Oh, good. Our first hiccup here. Let's see what we got. Try that one more time. So the interesting thing, what's happening here is in my terminal window, you see that once I ran that command, that consume command, it never exited, right? You can see because it never went back to the prompt. It just stayed open. And so that's a feature of the Pulsar client. When you go to consume, I told it I want one message. And so what it's saying is, okay, well, until I give you one message, I'm just going to sit open watching for messages. And then once I give you the one, then I'm going to get out of here. If there should have been messages sitting in the queue. So obviously it should have said, well, you want one message and you said the earliest. So there it is. Now I'm going to exit out. But for some reason it didn't. So let's go back and just stick a couple more messages on there and see what we get. So yet again, 2 messages were published there. And we're going to do my subscription. Okay. That's a little suspicious, but we're going to continue on. Okay, so back to consuming. So we said consume the earliest message and only give me one and then exit out, right? And so it gave me a bunch of debugging and logging and such. But the key thing is I'm looking for this got message line, right? This is very raw, by the way, if I didn't warn you. Using these binaries and everything, we're pretty deep into Pulsar. This is a very kind of raw thing. But it's that got message, and right below that, there's the content. Hello there, right? So this is the key thing. You got to see this and understand what you're looking at, because as we go through this lab, there's going to be a lot of this, a lot of back and forth here with these messages and all that. So I want you to be somewhat familiar about, okay, well, I got this output. Here's what I'm looking for. The key is content. Hello there. Hello there. That was our message that we put in. We've confirmed that we got that message back for it. Is everybody? I hope everybody's following along. Okay, let's take a quick moment as we go along here. And can I just get a feel in the room, like thumbs up? Is everybody kind of following along here? I hope these labs are fairly straightforward. Just let me know. Feeling in the producing, mine worked fine. Mine as well. Okay. Good. There's a thumbs up. I just want to make sure that everybody's following along, whether with me or, hopefully you're hands-on doing it yourself. So, okay, cool. So let's, I'll keep going here. So like I said, the consume command that we ran said earliest and give me 1, but we published 2. I may have more than 2 on there, but we published 2. There may be an exception in your production. Okay, we'll have to take a look at that. So now I want to say, give me the other one, right? Because we know we have 2 messages sitting in the queue. And so we asked for 1, which was the earliest, but there's another one there. So we can run that command yet again, and this should give us the other message. Now, it's the same content, right, as the other one. But the key is you've interacted with the broker, right? You published 2 messages. Now you got 1 message, then you got another message out of the queue. And you can read, there's the content, hello there, just get familiar with that, right? This is PubSub, right? You published a message and you consumed a message, and there's 1 of each on either side. Now, the interesting thing is, if you get into other brokers, we would have had to start up a publisher and a subscriber in 2 different terminals, in 2 different windows. And then we would have published a message, and then we would have switched over to the consumer, and we would have saw the consumption of that message. And it's all happening real time. Pulsar gave us the ability to do this in a much more controlled way. We published, and it sat there. And then we came in and consumed right after that, right? So we're doing this in a very synchronous fashion, just, on purpose, because we're getting used to this, interacting with this. But in my opinion, this is a very straightforward, simple way of getting started with a message broker. I've interacted with, what I guess would be the big 3 more than anything. I haven't gotten a lot of Kinesis, but if that's one of the big 3. Kafka and Rabbit, though, I've interacted quite a bit with, and I just felt like Pulsar was just much simpler, just a little more straightforward about interacting with it. Cool. Okay. So let's continue on now. If nobody has any objections, we're going to continue on to the next one. Yeah, so I did have a bit of a hiccup there, Rags, if you guys were talking about that. We'll have to go back and look at that, why I published 2 messages and it actually didn't see them, because I published 2 more and it was just fine. So we'll have to go back and look at that. That obviously is not the intended route. Okay, we're going to continue on to the next one. And yet again, unfortunately, I'm regretting my navigation here. Our next module, one small question. How does it handle that only one-time publishing happens and the message is still not being consumed? How does it handle that one-time messaging happens and the message is still not being consumed? Basically, in one terminal, I published one. In another terminal, I opened and published again. If I'm... Okay, thanks, Rags. So the question there, Devidas, I hope I pronounced that correctly. If I'm understanding your question correctly, basically, Pulsar, as I said, I think of Pulsar more of a playlist than like a first in, first out kind of thing. So like, I remember back when I was interacting with RabbitMQ, and so like taking the most basic of basics using RabbitMQ. And the reality that hit me as I created all these all these producers for messages was that I have to have somebody listening, right? If nobody's listening for messages on this topic, then where do these things go? What happens? And I learned that you can get into Rabbit and set up all kinds of fun, features and flags and settings and everything. But just straight up out of the box, you have to have a consumer watching for the message, or it's just going to go into the ether. And that just really, I felt made things difficult because I may or may not have a consumer there, but I want the messages there. And so Pulsar was the first time that it really, when I saw that, it resonated with me, saying, I can separate these two things. I can publish messages all day long into this thing. There may be a consumer, the consumer may be a batch thing that just shows up every once in a while and drains the queue or whatever. Very loose in that respect. Hopefully I'm helping answer that question. Okay, let's continue on. Now we're going to talk about functions. We did pub sub, right? Very basic, I understand, but we're keeping things straightforward. Now we're going to move on to functions. This is going to be a little bit more advanced, but still, I hope these steps are going to be pretty darn straightforward. So to create a function in Pulsar, you provide, cool, thanks. You provide a configuration for the function, right? And you also provide, I'm doing this in Java, so you also provide the jar that has the class inside of it. So for a moment, I'm going to switch over and let's look. This is called the exclamation function. And so first we'll see that the exclamation function is looking for the jar, right? That's already been preloaded in your environment. It's looking at the namespace, the class name, because it's going to create an instance of it, of that class to actually process things. It's only going to run one thread of it. You can change this number, right? You can really get into a lot of parallelism. It's all about how many threads do you want to run to accept function requests. What topic are we going to be watching? What topic is the function going to be processing messages for? Once the message has been processed, where will it go? What will the function do with it? And then, of course, our location, right? Everything has a location within Pulsar. It's tenant, namespace, that sort of thing. We named it, and we also gave it a log topic. And so that is, whenever a log is written within the function, where's that going to go? Where's that going to be available? And so for quickly, I'm going to be very, very quick about this. We're going to go in and look at the Java for this. This is the world's simplest Java. Well, if you had Spring, I bet you could do this in one line, but it's almost the world's simplest Java. And so we're using the interfaces defined in the org Apache Pulsar functions package namespace, right? And I brought that in and implemented a function interface in there, right? And this interface says you're going to bring in a string and you're going to give back a string. And so my function takes in a string as input. It adds a exclamation point on the end of the string, and then it writes it out of the function. Pretty darn easy, right? How it's being, so all this function does is the actual work. Very, very testable, very, very simple consumable thing here, bite size, right? That's the idea of a function, very bite size. Where it's going, where it's coming from, how many are running, all that sort of thing, that's all fed in when we actually start the function up. And so that's what we're going to do here. We're going to use the Pulsar admin binary. We're going to use the functions command and create it. And so that'll be, that'll run there. That should give us just a happy created successfully. If we've given it a proper configuration, it will automatically start the function for us. So we're just going to confirm that by looking at its status. And what I'm looking for is running is true, right? One instance, running is true. This is good. And so behind the scenes, so that you kind of understand this, because this is getting back to the cloud native aspect of this, you have to understand where you're in a synchronous state and where you're executing things synchronously and where you're running things asynchronously, right? Many instances of the same thing. And so this is a great example of that. Because we're running in standalone mode, we've started up an instance of this Java class in a thread in the background, right? On our little instance here, in our little environment. You could run functions in a completely different VM, right? A completely different machine if you wanted, give it a different build. If you're running like hard functions, you're running involved ML kind of stuff or whatever, you can configure this in many different ways to do some nice things. But this is like the world's simplest function ever. So we're not going to push things too hard. So we're going to go ahead and produce a message just like we did before. Our hello world or hello there string. We're going to do 2 of those. So I'll go ahead and send it into our exclamation input topic. And yes, they were produced. And so now the function should have taken in the string off that topic, added an exclamation point to the string, and then published it to another topic. And we are going to confirm that because now we're going to do a consume. And we're going to say earliest. We're going to say, give me the 2 messages on here. And we're going to say, look at the exclamation output topic. So if the world is spinning in my favor, that'll come back. And so notice we have 2 got message log entries here, right? Because we asked for 2 messages. And look at that. Our string now has an exclamation on the end of it, right? So our function processed everything and confirmed that everything's worked just fine. So before I continue there, because there were some moving parts and everything, again, if you have any questions or anything, please put it in the chat. You know, I feel like I may be moving a bit quickly. I hope I'm not. And actually, I see Rag's got a message here. Can you please clarify a question about parity between different language drivers for Pulsar? Always a challenge. Yes, it is. Let's go up. Primary challenges of Pulsar is on the non-availability of features. Yes. Yes, Arnab, I'm right there with you. I'm personally aware of the C# library more than half. Yes. Oh my gosh, I am so there with you. So let's take a moment here and pause for a minute. So we're using the binaries here to publish messages, to consume messages, to do, interact with the broker, right? The reality is you're rarely going to do this. Administratively, you might want to do this to diagnose something, but the reality is you're not going to go to production using the binary for that. What you're going to do is you're going to use a client library in your application, probably a microservice or something like that. And the client library is going to give you the ability to connect to a Pulsar broker, produce messages, consume messages, open up observable things, open up watchers, do all those kinds of things, interact with the broker and do these things, all programmatically, right? The languages, as you go in and look at Pulsar, the clients right now that are created out there, the Pulsar clients are the Java, Python, Go, Node, C#, and I believe that's it. I feel like I'm missing one, but I think that's it. So those are all the clients out there for it. Pulsar is written in Java. So the Java client is 100% in parity with the latest version of Pulsar, right? That's they're testing and everything using that client. So it's 100% in parity. The other ones are not guaranteed to be in parity. And it's kind of an interesting thing because when you go in and say, oh, here's a C# client library for Pulsar. Okay, well, what version of Pulsar does it cover? It covers whatever 2.9.1. Fine, then I get all those features out of it. Not the case. Because ultimately, underneath the covers, Pulsar is using WebSockets, right? And so it's using gRPC more than anything. And it defines its protofile, its gRPC protofile. And so these clients are using that protofile to implement certain functions, right? And unfortunately, some of the clients implement some of the functions, but not all of them within the proto. And so an example of that is Pulsar functions, the thing that we just ran, are not supported in the C# client, in the C# Pulsar client. It was a hard reality that hit me when I got into it. Pulsar functions are supported in the Python and the Go clients. So it's kind of hit and miss there for it. Unfortunately, that is a reality of how new the project is, right? As things go and the community consumes all this more and wants more out of it, these clients are going to be built up more and more and more. I can tell you that it's like daily, everything is growing and getting more and getting more. It's so hard to follow the project. But anyway, Arnab, that was a long explanation, but I hope I gave some clarity or touched on your comment there. Okay, back to our functions. I digress. So we're going to add a function. We're going to add a new function, right? This new function, this is going to do something a little bit cooler. So now we're going to categorize messages more than for this. So the first thing is we're going to create this. We're going to call this the filter function. And I'll let you go in and look at the YAML for the filter function. We're not going to go there. But what I do want to point out is if you go in and look at the Java here, then you're going to shake your head at me and go, what kind of code are you writing here, David? And I promise you, I'm a better programmer than this. But this is a demo. It's quickie. We want to get something done, right? So there's not a lot of exception handing in here. There's one big try catch. I understand. There's uppercase and lowercase everywhere, and not ideal and all that. Please bear with me. But the thing that I want you to notice is this function, its implementation, its interface implementation is taking in a string, right? Give me a string message. And then it's actually it's a void. So it has no return on it, right? Internally, it knows about what topics that it wants to publish to. You do give it the context. And so the context is an object given to you by Pulsar of this is where you're at. This is the tenant you're in, the namespace that you're in, the topic that this message came from, the encoding that's being used, all kinds of good things, right? The context. The context also gives you a logger in here, right? That's kind of a nice freebie there. And so I wanted to show you writing some messages. So every single time a message comes in and is consumed, it's written to the log. And then it does this very fancy switch statement on looking at it takes in some JSON, right? A huge assumption there that the message is JSON. It parses the JSON down. So we're just using a little JSON library and all that to parse it down into a nice object. And then it's looking at the purchase category. And it's saying, is the purchase category a lamp or a desk? And if it's one of those, then it's going to forward the message on to a different topic, right? Kind of a cool little quick filtering thing going on here in the Java. Okay, so let's go ahead and load our filter function in. We could go in and look at the status of it. We're gonna just get a little crazy here and not check the status of the function. And so first I'm going to publish a message. Now look at the message for this, the string. It's JSON, right? It's been the double quotes and things have been escaped out, right? But it is straight up JSON. This has errors written all over it. Please give me an error. But again, I'm just getting something done very quickly. So the message was published. One message successfully produced. Good. Now we're going to publish one more message. And this message has a purchase category of desk. And so if our function has worked correctly, we should be able to go into the lamp purchase stream and see that there is one purchased lamp in there. And there is, right? We went in and said, lamp purchase stream, give me the earliest, one message. We find our got message log, and there is the content. Now I just forwarded on the message, right? So it's just the JSON there, but we could do all kinds of fun things here, right? The categorization of things. You could put an ML model behind this, and you could take that JSON and feed it into some nice ML decision making for it. You could manipulate the message and then send it on to many different streams, many different lines of business that are interested in knowing about these things, or send it to different stores or things like that. My intention here is to just really open your eyes and see all the different possible ways that you could get this done, and hopefully how straightforward some of this is as you get into meeting Pulsar. So I just did the other one, and so to the other topic, and that is a desk topic, and yes, it published over to the desk topic. Okay, so now I'm going to look at the status again, because a nice little feature is the functions. When you go in and look at the status of the functions, it will give you latest user exceptions, and our collection is empty, which is nice. And num system exceptions. So this is kind of a nice way to very quickly look and say, is this thing working properly, or is it misbehaving, and what's going on for it? The logs are written in quite a few different ways for consumption. Because we provided that log topic when we created the function, the logs were automatically dropped into this filter function logs topic, right? All of that was done for me. And so that's really the thing of interest for me, because in here, we're just going to open up a consumer here. In here, I can see all my different log messages. So if I had an exception, an exception stack, or needed to get to exception information, it would all be in here, right? And this, like, when you get into production and all of these fancy systems are using all these different brokers and publishing and consuming and all that stuff, debugging this stuff is difficult to do. And so when I saw this feature of just give it a log topic and it'll dump everything in there, oh, thank you. Because I can go to production with this, and my production team and my security team and all that, this follows the model of the system, right? So this is a very acceptable thing, but I can get to relevant information for me debugging what's going on. I just really loved this feature for it. All right, so we're going to continue on. I'm going to have a look at chat. Redis has the same problem with C#. Yeah, it does. Yeah, that's the Arnab. That's the life of a C# developer right there. It's always on the go, having to contribute code, because we're always one step behind a lot of different projects. It's just how the ball rolls. What does it store in the log? Does the message ID also? Yeah, Davidas, you can pick all kinds of stuff, right? If we go back into the Java here, I just chose to log some super basic stuff. What's the topic and what's the message? What's the content of the message? Because you have this context here, you have the whole world of information at you, the message ID, whatever you want, and just parse it into a log message and go for it. So absolutely, you can put whatever you want in the log. Okay, so now we've done a basic pub sub. We moved over to functions, and we did functions. So I hope that was basic, I know, but I hope that really got your wheels turning and showed you how powerful Pulsar can be, and how many cool things you can do with it, right? When you get into real-time data streams, as you're going to see on every piece of marketing that ever comes out of our company, things like that, like the click stream pattern and all that, or maybe your team or your organization is saying, like, we need to get better at learning from our data. real time. We need to get better from learning from our data. The function, in my opinion, is your fastest way to that, because you can take information in, you can process it through however you want and spit it out. But as the developer, you really just care about getting through the information and making sure that the messages were processed correctly. And that's like, I feel like you can stay in your domain, in your interest area, and not deal with all the infrastructure stuff as much by using these functions. Again, it really resonated with me, the functions and all that. So our last piece of this is, back to this navigation. We're going to add a source connector. This is our last one for this lab. And so in this, the idea is, so we've been writing messages manually into the broker. And that's not realistic. For debugging and all that, that might be, but that's not realistic. You're going to have something automatically creating the messages along the way. A database, a data store, an HTTP endpoint, something is going to be creating the message. And so this is the attempt, or this is a demonstration of creating a source. Later on, we're going to look at a sink for it. We'll get there. But first, let's look at a source. And so this source is going to say, I'm going to watch a file. I'm going to watch a local file. It's the mymessages.txt file. I'm going to watch that file. And anytime something is written into that file, I'm going to turn that into a message and put it on a certain topic. So again, the definition for this is in the YAML. I actually will go look at the YAML for this. This is ultimately, this can be a regex or whatever. I just kept it super simple and obvious. So this is the directory that it's in. Here's the message that we're looking at. This file source is the world's most basic source, right? I'm more interested in showing you the example and the pattern of doing this than like saying, hey, use files as your source. That's probably not a very common thing to be done. All right, so let's go ahead and create this source. Whoops. Got to get out of I started up the consumption and left it open. And there's my source. And so let's look at the status of that. We'll make sure that it's running. Yes, it is running. Okay, so now let's just take one of these. And now, every second, so in my YAML, I said every 1 second, 1,000 milliseconds, pull this file. Look for changes in this file, right? I'm not going to open up the file. It's closed, nothing going on. What I'm going to do is I'm going to write one message to the file. And I'm writing one message to the file, which will then make it onto a topic. So there we go. I wrote one message to the file. Now, if my source is working correctly, I should be able to go in and consume on that topic, and Pulsar should have added that message to the topic. And it did. It added the message in. There's the content of the message, my first message, and there's the source and all that good stuff for it. Now we could also, if we want to get fancy here, we could open up the, let's open up the file. Let's start an open-ended watch, right? Notice N is 0. And so that's telling the Pulsar client, I want you to watch this topic continuously, indefinitely. And so I already have something in there, so it appears like it's kind of freaking out a little bit because the message is already in there. So now I remove that out. I'm just going to write some things. I don't have to do a line ending or anything, but what we're watching for is look at content, right? Whoops. Let's go to a 3. Let's go to fixes. Now, let's do equals, right? This is, I just want to show you the point of how this is working. Now, one oddity you might see, I'm going to clear this out and I'm going to kill the watch here. I'm going to do a Control-C in my terminal window, and that's going to stop the consumer from watching. So what you might notice there is the content of the message was repeated over and over and over again. right? That is just a product of us doing this demo where we're only moving as fast as me talking, right? So when I go into that text file and I start writing things and all that, it's just going to continuously see them because it's just continuously pulling the file saying, got a message, write it. Got a message, write it, right? It's not looking at, oh, I already wrote that. It's not idempotent or anything like that. What you could do in this file is, notice I said keep file as true. What you could do is say keep file false. And then Pulsar would look for the file. Once it gets a message, it would delete the file. And then something else on the other side is creating the file again, and then it would delete it, right? Maybe you've got a logger and it's writing logs to your disk. And then Pulsar's every once in a while pulling it, grabbing all the logs out of it and putting it onto a topic, right? That's kind of a cool pattern because now maybe you have a legacy system and the logs for it are being written to disk and there's not much you can do about it. Maybe you can't get to the source code of it. Maybe compiling that application is like, it's one of those things where it's like, this is the white Yeti. Don't anyone go near it. It's in production. It's been running for the past 15 years. Don't nobody touch this thing. But it's writing logs to disk and you need to get to them. This could be a cool way to be able to get those logs out in an automated fashion onto a message topic, right? And then you can consume it in a much more realistic way and do some more modern things there. That's what I want to get your mind going about, thinking about all these different cool ways that we can use Pulsar to do all these different cool things. And we're at an end. You made it. You survived. Congratulations. You did it. And so now we're going to check the chat. We're good there. I want to check the time. We are halfway through. I promise the next half is not going to be as painful as the first half, so just bear with me. So now we're going to switch back over. Thank you, Jorgen. If you guys want to just drop a thumbs up, I want to make sure I haven't put you totally to sleep yet. You're still awake, or maybe I just woke you up. That's cool, whatever. I just want to make sure that if you have any questions, or you're like, you know, I got the wheels turning here and you're thinking about things, how I could use Pulsar, maybe with legacy systems or with new modern things or whatever, like, please drop those ideas. Drop those questions or ideas in the chat. I may not be able to get to every one of them, but I'd love to hear about what you're doing. I am reviewing the chat, and I'd love to hear about what you're thinking about. Maybe I could use Pulsar for this, or here's a business challenge or something that I have, and maybe Pulsar could fit in there and you know, do some cool things for it. And we're going to move on. Awesome. So now we're going to get a little more producty. We're going to get into Astra side of things, Astra streaming. And so this side of things, we're going to go through a couple of slides, and I'm going to do some on-screen things here for you, but I want you to grab some popcorn and sit back and relax, because you don't need a keyboard unless you want to give us some ideas in the chat. You don't need a keyboard for the next little bit. So Astra streaming. So the idea with Astra streaming at its absolute simplest is manage Pulsar, right? Our team, our engineering team are very, very big contributors to the Pulsar project, are helping steer the project, and as such, know Pulsar inside and out and every way forward, right? And so they've taken that and they have created Pulsar clusters and made a managed product out of it. So it's Pulsar as a service, right? That's Astra streaming. Obviously, it's cloud native. If you're familiar at all, I hope you are, with Astra and its abilities with Cassandra. All those same principles and best practices, they all carry over into streaming. The nice thing is, like, the code that you're writing, the way that you're interacting with the broker in Astra streaming, you're interacting with the Pulsar broker, like straight up. You're interacting with the Pulsar broker. So there's very little lock-in here. Short of choosing Pulsar as your broker, short of that, you're not like locked into DataStax libraries or anything like that. You're using Pulsar stuff. All of the examples that we just did with PubSub and functions and all that, those could have carried into Astra streaming with very, very little effort. Just point it to a different broker. Also the cool thing is, as you get into this and you maybe are learning about event streaming and what it is, and you're just kind of wrapping your mind around these new asynchronous way of doing things. Maybe you're getting into event architectures and that sort of thing. This is all free, right? You don't have to worry about spinning up a Pulsar instance, having it going. You could do it in Docker locally. You could do a little cluster with it. There's a little bit of Terraform out there. There's Helm charts out there for Pulsar, and that's all fine and well. But if you just want to get going, give me a running broker. I don't care about any of that. I want to get into writing a client or interacting with it. This is a super easy way to do it with Astra streaming. And I, for one, really appreciate that, because that's what I want to do, is get into it. If you're familiar at all with Astra, this is going to be super convenient. This is going to be very, very straightforward getting into this. There is, every month you're given a credit. So that's the freeness side of this. If you want to get into, going into production and doing some more real things, and your message consumption, of course, will turn up at that point. This is a consumption-based model, right? You pay monthly for what you've consumed. I'm not going to get into the billing strategies and all that right now. But anyway, that's how Astra streaming is arranged. And then easy management Pulsar. So actually, I'm going to go past this because I want to. I actually want to prove that a little bit further. So let's log in to my Astra account. There shouldn't be much of anything in here. We'll give this a minute. Yeah, like nothing. Like this is brand new. Freebie account, right? And so on the left over here, I'm going to go to create a stream. Tenant name. We now know what that means. What is a tenant, right? I'm going to call this my product line. I'm going to choose a cloud and a region to go in. We're just going to do Google Cloud US Central 1. On a freebie account, I believe you're only given access to 1 or 2 clouds to spin your broker up on. But when you're testing like that, I don't know that it really matters much at all. So let's go ahead and create that. So now take a moment. When you spun up that Git pod, and I said you have a fully working Pulsar environment, but it's in standalone mode, so a lot of things have already been assumed, and the tenant's been created, and all that stuff for you, we are in that exact same place now on Astra streaming. We gave it a name, it spun it up, and we now have a fully working tenant. If I go over to connect, I can get a bunch of different snippets for how to interact with the broker, right? A bunch of pre-made libraries and that sort of thing. Also, in Quick Start, you remember, where is it? The clients.com. So you remember in our, I'm going to switch back over to our Git pod for a minute, because you remember when Apache Pulsar started up, if we look in the top left, it created all of these folders. And one of those folders is conf. Conf is telling the binaries how to connect to the broker, which broker to connect to, right? We're connecting to a broker that's running locally within this Git pod. But over here, I can take this client conf, drop it in that folder, overwrite what's in there, and now all of your creds and everything are preloaded, and now you're connecting to this broker, right? All those same commands still apply. You're just using this broker instead of that broker. I hope that's pretty straightforward. Just like in the standalone version, there was a public topic that was created. Default namespace on a public topic, right? So if I go over to namespaces here, there's the default namespace. So same idea as far as naming and all that. It just spun everything up individually. If I go into this namespace, I can see a little bit of stats. This is kind of nice to see messages coming in and out and what's going on. If I come back over here to topics, I can create a new topic if I'd like. I let Pulsar pretty much create everything for me as we go through it. Functions. So remember, we did the function and we had a config file, and that config file pointed to a jar, and we had to give it some stuff. Well, here's a nice interface for it. Name the function, put it in the namespace that you want to go in, upload your code, that's the jar, the input topics, the destination topics, some advanced configurations, same deal, right? That YAML that we were setting for ours now is just a nice interface for interacting. I'm going to skip over to sources, same idea, right? The difference is here, these are pre-made. So Astra Streaming only supports a certain amount of sources and syncs for it because they only know so much about it. I can promise you this list is going to grow. Without a doubt, it's going to grow. But there's some very cool things. Cassandra source, so you could have a Cassandra database in AstraDB and have it connected over here. We can go to Kafka. So if we choose Kafka as our source, then we're going to give it some connection information to get to the Bootstrap server and all that for Kafka, and some SSL and all that to get in there. And then whenever something is being written to a topic in Kafka, this automatically knows to watch for that and publish it to a topic in Pulsar, right? So we can move between the systems, but there's like no code to do any of that. That's kind of cool. Same with Kinesis as well. You can connect up to AWS Kinesis, and when messages are being written over there, you can have them written into a topic here. Then you could possibly use a function or whatever over here. On the other side of that, the syncs. And so this is whenever information is written to a topic, I want you to automatically write that information to some other system. And so that some other system, the type, are pre-made in here. And this is actually quite a long list for Pulsar, the Pulsar project. Astra Streaming, this list is growing very quickly. But you can sync to AstraDB, to Elasticsearch, Kinesis, Snowflake. So the idea here is, I'm going to say whenever a message is written to this topic in Pulsar, I want that message to automatically be written over to this Kafka topic, or this Kinesis topic, or this Snowflake database, or whatever. All of that is pre-made for you. You just give it the connection information and then grab your popcorn and hang out. The try me, so this is a nice way to just get in and do this, right? We already have everything here. I'm going to go ahead and do this. So we had we got to create a topic for this. My new topic. I will let it be persistent. Let's add that. Cool. Let's go over to README. So default namespace. I'm in this tenant, right? This my product line tenant. I'm in the default namespace, and I'm looking at my new topic. That's the topic name. And I'm actually going to consume from here as well. That may seem a little bit odd. We're going to have a subscription name and a subscription type. We'll do a shared. These values, right, these should be pretty familiar to you because we just did all this hands-on, right, interacting with it. The connection type is consume or read. Like all of these things, the read position being earliest, these were settings that we provided in those binaries to do this. So now it'll connect over to there, and then I can write a message. So I'm writing a message to the topic, and then it says, yeah, I just saw this on the topic. So just kind of a cool way to interact with the topic and test things, see what's going on there, and just see what you can do and can't do, and that sort of thing in the try me. Let's take a moment and check for any questions or anything. Are we good? Looks like we're doing pretty good. Cool. Okay. So the thing that I want to really drive home the most is the reason that we did the hands-on with a local Pulsar broker, and we did all those binary commands, was so you could be at a very raw place interacting with the broker directly. And we did a little pub sub, and then we did a function, and then we did a source, right? Very, very basic things. But now when you come up to Astra Streaming and you want to use it, the naming up here and the things that it's asking you for, I hope are a little more familiar to you, because you've seen it, right? You know how it's being used and how it's being interacted with the broker. But the value here is you can just get in and get going, right? I can connect, I can use the broker, I can set up namespaces and functions and that sort of thing. and I can choose whether to like get into a full client and write code or whatever. And then, you know, you're on free credits to do a lot of this stuff. So I thought Astra Streaming was pretty darn cool to get in and get going with Pulsar. Obviously, when you want to turn it on, you want to go to production with this stuff, you're on Pulsar, right? And you're on a very large cloud footprint for Azure. So the latencies here and the ability for these brokers to be able to ingest a lot of information very quickly, that's just handed to you here. Well, you get to pay for it, but you get where I'm going with this, right? The managed Pulsar instance. All right, now we're going to continue on, and now we're going to meet change data capture. And this one, I promise you, I'm going to keep this as painless as possible because I feel like you probably have a decent amount of background here, so we should be able to talk to this fairly quickly. The classic pattern here for change data capture, I have some RESTful APIs, right? X, Y, and Z have some RESTful APIs. They're public facing probably. They do different things. They cover different domains of knowledge. They're all writing to a data store, the same data store. What ends up happening there is when account needs to look up billing information, hopefully it's going to that microservice to do it. Maybe this is a monolithic application, right, where it's just one big deployment. And Team X, Y, and Z are just maintaining bits and pieces of that overall solution. And everybody's using the database. You're basically using the database as a message queue, right? Because everybody's using that as your system of truth for your records. So the idea is, as these different things write information to the data store, instead of going back and reading everything from the data store, we would like to get this information, this change, into a message broker, right? Well, it turns out that pretty much every database out there, if they're not super fancy and modern like Cassandra, when you're using, you know, MySQL and Postgres and MS SQL and all that kind of stuff, they have a transaction log, right? And it's a log happening every single time that you interact with a table. And it's all the CRUD events, right? Add, remove, delete, all that kind of stuff. And that transaction log is happening all the time. There's no overhead there. Like, it's already been designed in, that overhead. So can we get that transaction, that information in the transaction log? What was changed? I want that to become a message in the message broker. That is the change data capture pattern, right? Is watching that transaction log and getting that information into a message broker, change data capture, right? Okay. The question is here, how are you going to complete the pattern? What are you going to use to complete the pattern? What kind of database do you have? What do the transactions log look like? How are they getting parsed to get that message information out? What message broker are you using? How are you connecting to that? There's got to be a long-running process here, watching those transaction logs. What's that? Who manages that? You know, all of that kind of stuff. That's where you get into really the architecture of change data capture. And so that's what we're going to introduce with the CDC feature of Astra. See, there's a question in the chat. Pulsar have the flexibility to deal with mainframe DB2 data change. It does. So don't think about specific data stores like DB2 or something like that. Think about, how can I get the change of information, what was changed in my DB2 database? How can I get that out, right? DB2, it's been a while since I've done DB2, but I'm betting that there is a transaction log there. And Debezium might have a DB2 adapter. I'm not sure. And so that's what you're thinking about here, is how can I capture the change in information? And ideally, I'm not going to put any more load on the database to be able to capture that change of information. And then after I've captured that change of information, how do I get that over to something more modern, something more consumable, you know, in the organization, more modern applications and all that? That's where I want your mind going here. Plumbing is a very good way. Thank you, Rags. That's a very good way, a very good word to use there. And then once you have this message broker, then you can do all kinds of fun modern things, right? You can have maybe long-running CLIs that each of the teams individually manage. And those CLIs use a Pulsar client library to publish and subscribe messages from the broker. If your transaction log messages, your change data capture information, that's being written to a topic that represents the table that it came out of, right? And so my table is called account information. And so it's going to the account information topic. Team X, who is responsible for account functions, can watch that topic and say, oh, this account was just created, or this account was just updated, or they can do some other things. And then they can put another message on another topic to say, billing information needs to be updated for this, or logging needs to remember that this was done, right? The cool thing is your monolithic application using that data store, untouched, totally untouched. It's just right into the database as it has for the past 52 years, which nobody can ever go near. The cool thing is you're doing things outside of that in the environment to make this act a little more modern. Okay, I hope all our questions are getting answered. I think we are. DB2, thank you for that. You've really taken me back. Appreciate that. All right, so I hope that the CDC pattern, right, of change data capture and why this matters, right? This hopefully should really get the wheels turning here. Like, think about if somebody comes in, your leadership comes in and says, we need to make this whole application real-time data streams, right? And we need to refactor this whole thing, rewrite the whole thing into real-time data streams because that's where everybody's going and that's what we got to do. Yeah, thanks. I'll see you in 10 years, right? But it doesn't have to be that way, right? You can hook up a CDC pattern, leave the application the way it is for right now, and make data streams happen on that existing change data, right? That's a really awesome thing. And I think very, very powerful because I've definitely been in this situation doing that. Does this work with system generated events as well? Kat, are you talking about system generated as in database? Or that sort of thing, schema evolution. Yes, schema evolution is a thing. And in fact, you're walking right into my trap with schema evolution. So I think that's really, Kat, I think that's really about what's getting captured in the transaction log. I'm hesitant to say yes for sure, because I'm betting every database is a little bit different there on what information by default they write to transaction log versus what they've been configured to do. But I mean, I've played a lot with MS SQL coming from C# and all that, and I know there's a lot of system generated information in there for sure. For sure. Can we use CDC pattern to achieve some level of consistency level in non-ACID transactions? You could. I guess that really comes down for me to resilience more than anything, right? Because you have messages over the wire here. And so what's your level of tolerance if a message gets dropped, right? As much as I would love to say that Pulsar is perfect and awesome and all that, there are some realities here. And you're going over the wire at some point, and packets just don't always make it there, right? So I would say that's more about how resilient is this going to be? How much latency and fault tolerance are you built into this? How far do you want to go with that to ensure that consistency or maybe regulate that consistency? I hope that helps. Okay, so now that we've got the CDC pattern down and we've got the idea, it looks like I kind of got your juices flowing here. Now I'm going to show you in Astra how we've completed this, right? Getting into Cassandra and all that. So this is the first time that we've married these two sides up, Astra DB and Astra Streaming together. And so the way that I want to show you that is through a quick little use case. I create a table in Astra DB, right? Straight up table, nothing real crazy there. I am automatically given a feature in Astra called Enable CDC. It is a new tab that shows up. In fact, I'll switch over there in just a second. In fact, bear with me a minute because I want to get the database going over here. Let me just get a database happening. We want to go here and here. And we want to go US Central. Okay. That's going to take probably just a minute to get going. So we create a table in Astra DB in our Cassandra database. We enable the CDC for Astra feature. That's just a checkbox to enable that feature. And we create a tenant in Astra Streaming. We just did that, right? Automatically, CDC for Astra is going to say, what is the schema of the table? Okay, now I know what the messages look like, the shape of the messages look like. I'm going to create a data topic and a log topic, and those correspond with what's going on with the table. The data topic, that's the one we're interested in here. Those are going to be messages of following that schema. They're validated. They're totally legit messages. They're not just like free text or something. That's the thing. That's going to be one record of information, and it's going to tell you this is what changed about this. So all that's wired up for you. All that happens for you when you enable this feature. Then we could create a sync, and we did that before. We looked at the list of syncs and all that, and it could go to some downstream target here, right? So we have a database. We change something in the database. We have CDC enabled for it. That information that changed, really the whole record, goes into the data topic, right? All of that is done for us and validated for us. And then we hook up a sync to that data topic and say, whenever something happens here, write it over to this other place. Or we have some consuming application that's watching that topic, looking for information. So going back, I want to go back for a minute and say, like, talking about all this, the CDC pattern, right? We've accomplished this pattern using Cassandra as our database, the CDC for Cassandra features, along with some other long-running things in the background, the Pulsar broker for everything to create the topics and all that, right? That's how Astra, or CDC for Astra, completes the CDC pattern and gives you, all of this with really just a couple of clicks. It's pretty sweet what it does. In terms of messaging and all that, event streaming and everything, this is our streaming producer. This is the thing producing messages and putting them onto the topic. Remember, we were doing producers before. And then there's also a streaming consumer, and that's watching the topic and writing it to some other place. All of this is done in the background and all managed for you, right? This is a part of the feature of CDC for Astra and how we've married up Astra DB and Astra Streaming together to create this awesome CDC pattern. Okay, that was a lot of talking. I hope everybody's still with me. So let's see if our database got created. Just refresh here. Cool. All right, database is up. So I'm going to do a quick time check here, and we've got about 24 minutes to go. So actually, I'm going to take a poll here to the group because we could go a couple of different ways here. The homework for this is going to have you come into Astra and complete the CDC pattern, right? The homework is going to give you a step-by-step. I'm going to give you the repo, and it's going to take you through a step-by-step for creating a database in Astra DB, creating a tenant in Astra Streaming, and then enabling the CDC feature, hooking everything up, and ultimately writing one record to the database and seeing it all complete for all that. I could go through that here, doing that. And that's all fine and well if you guys want to see this whole thing happen. Or we could just continue on, and I can leave it up to you in the homework to see CDC working and keep a little bit of hands-on there. Any opinions out there? What you'd like to do? I prefer you do the homework, because I like to see, that you're not sleeping. But that's just me. Okay. It looks like there's very little opinion out there. Either I've put you completely to sleep, you've left, or you agree with me. Okay. It would be nice to do homework along. All right. Then I'm going to, seems to be the opinion of homework. Cool. Well, you made my life easier. I appreciate that. Okay, so let's continue on then. And let's talk about the homework. So we're going for a super cool badge, right? You're going to get a little bit of refrigerator recognition in the house because you get your badge on the refrigerator. You got to do that. So here we go. We're going to post the link. I will do that. So I'm going to post a link to the homework form there in the chat. And so the gist of what you're going to do here is let's just head over there to the form. We've got a couple of questions to be answered about making sure that you didn't fall asleep, or maybe that you are good at cheating or whatever. I don't care. Just answer the questions. So you've got a couple of questions to answer. Then it's going to ask you to go into the CDC for Astra guides, which I am going to go over to. There we go. Right, it's going to bring you over to these guides. And you're going to go into the Astra DB Sync guide. And so what this is going to have you do is you're going to check your cloud regions. You're going to create an Astra account if you don't have one. It's free. And then you're going to come in and do all the things that I was talking about. You're going to create a database. You're going to warm it up. You're going to create 2 tables in there, a system of record, that's the all accounts, and then CDC. You're going to create a tenant in Astra Streaming. Then you're going to enable the CDC feature, and that's going to kind of wire things up. And then you're going to go in and add a record in there and do a little bit of warm up on the topic and all that. You're going to add a sync. Now the sync, bear with me, the sync is Astra DB, right? So our source is effectively Astra DB table. And then we set our sync to be Astra DB as well. So when we write data in one table, it's going to go through Pulsar and back to another table in Astra DB. The purpose of this is just to show you the completed pattern. And you can do it all in the browser. It's pretty easy and straightforward to get through all that. That's really the idea. You probably wouldn't be doing that in real world, but again, I just want to iterate emulate the point of what's going on. So that's the homework here, is you go through, you do all this, you set up the sync, so on and so forth, and finally at the end, you're down to this. And so when you get down here to this, what I'm asking is that you do a quick screenshot of that select star from that CDC table and include that with the answers to your questions in that Google form. And by the way, if you take this screenshot right here and you bring that down and you post that in there for it, I'm not giving you a badge because there's a good right here. And you're not going to recreate that good, so don't do that. Do it yourself. Do the homework yourself. Don't cheat. And send me a screenshot of that. That's the homework. Complete the guide, answer the questions, submit a screenshot, earn a badge. Simple as that. Sorry. There's a humongous caveat, though. And we just discovered this. When you're going to set up a database in Astra DB and you're going to set up a tenant in Astra Streaming, they have to be on the same cloud region. That's a requirement of Astra to be on the same cloud region. Well, as it turns out, in a free account of Astra, you can't. On a free account, the free cloud regions are not the same between the two. So I've also given you a super awesome form. If you give me your email address, your login for Astra on that form, I will go in and open up your Astra account to all cloud regions temporarily so that you can complete all this and get all this through. And I'm so sorry that we have to go through this hoop. It was something that we discovered late, not too long ago, and I can promise you that our engineering is all over this to fix this. But it's where we're at right now. So just understand that you do have to jump through a few hoops to get this badge, but your badge is going to be on the fridge. Totally worth it. I mean, come on, it's a DataStax badge. If you have any questions or anything, please head back to our Discord. There is a workshop chat channel. There are Pulsar channels, streaming channels, Astra streaming channels. Go in any one of those. We're in all of them. Post questions anywhere, and I promise you, myself or one of my Jedis that I work with, one of us will find the question and we'll get something back to you. We're pretty darn quick about getting back there. And now the shameless plug, as we come to an end, is subscribing to our channel, our YouTube channel and all that. Uh-oh, our moons is covered up. So Stefano, I'm wondering if I've broken the rule here, if I'm covered up now. You head over to our YouTube channel. You're probably already there. Please subscribe to it. Right? There's a lot of good content on there. We're doing these workshops all the time. So subscribe to them and we'll let you know about everything going on. I've got some more workshops coming up. We're just booking these for talking about real-time data streams, right? So we're going to use all this Pulsar knowledge that we have, and we're going to apply it with a little bit of ML, and we're going to let some clickstream data come in, and we're going to make some real-time decisions, and then emit some clickstream decisions out, that sort of thing. That's going to be the workshop for you. All right. Thank you. That was a lot. I hope everybody, you're walking away a little bit smarter out of all of this, understanding where Pulsar is, understanding about Astra streaming and all that, maybe seeing some value there, I hope. But more than anything, I hope you've learned something, maybe about event streaming, about some patterns there, got some thoughts about how you're going to get into a little bit heavier asynchronous programming, that sort of thing. That would be awesome. I'll have one more look at chat real quick. If you have any questions or thoughts, please drop them in there. Can you post a link for the homework detail? I can. Let me go back. And you want to go to that form. And so we'll go here. I'm going to give you, that's the, oh yeah, there we go. There's Philip, there's your link for the form. And then it has all the stuff in there for everything. All right. Final thoughts, questions, anything like that, drop them in here. I thank you so much for your time. Again, I really, really hope you've learned something, that you're taking something away from this session that's, beyond products and all that stuff. I want you to learn something with this time. I want this time to be valuable with these workshops. So as always, if you have any feedback, if you have any thoughts, if you have I wish you guys would do a workshop about this because I'm wondering about, these patterns or whatever, come into our Discord, drop those ideas in there. We're open to it all. We love getting ideas from folks about other workshops to do. All right, I appreciate your time. We're a little bit ahead. You're welcome. We're about 14 minutes ahead. So go do the homework. 14 minutes. Knock that out. I'll be watching for your requests to open up your accounts. Thanks, everybody. Have a great day.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.
A being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.